everyone, welcome back. In this particular video, we will be discussing the problem longest substring without a repeating character. What we are given is a string. What we need to find is the length of the longest substring which has no repeating characters. So we have to find such a substring, only the length of it, which is the longest first of all. But obviously the longest substring of a string of n length will be n only. So the constraint is the longest substring should not have any repeating characters. That is, all the characters should be unique. All the characters should be different. If you are able to find such a substring, print the length. Among all those substrings, the valid substrings, find the maximum length actually. So let's take the first example to understand the problem. If the example given is double A, B, triple C, B, C, B. If this is the string given to us, what is the longest substring without repeating characters or with no repeating characters? If I take A, I can only take one times A, either this one or this one. But if I take this one A, I can also take B. In fact, I can also take C because all the three characters are different. But now I cannot take the next C because it will be repeating. If you will start from this C character, you will only be able to take two characters. Similarly, from B, only two characters can be taken if you don't want repeating. So the actual maximum length will come out to be for the substring ABC, which is 3 only. So output is 3. Similarly, if we take the example C and then a lot of D's are there, in this second example, as you can see, there will be only two length string which is having different characters. Because as soon as you take one more D, it will be repeating. You don't have to take repeating characters. So these were some simple examples, sample test cases only. But what about some difficult test cases, some enhanced test cases? So for that, I am taking a string containing A, B, C. Then let's take the characters with some distance in between them. A, B, C, B. Then let's take D. Let's take E. Let's take F. Let's take G. Let's take A. Then F. Then let's take G again. And let's take now maybe E. If this is the string given to us, we need to find the longest substring with it, which is not having any repeated characters. So what is the longest substring, as you can figure out, which is not having repeating? If I will take this D, I will not be able to take this D. That is till this point and till which previous index. Since there is a, I will have to stop my loop or stop my substring till any repeating character. And most probably what we can do is we can take all of these characters, as you can see, because there is no character being repeated in this entire substring. So I think the longest substring without repeating characters will come out to be this one. Let's just make it little bit smaller by making some other character also repeated. That is, let's also take this character as the character which is G. And let's now try to figure out the longest substring. So one of the approach which you can actually use to find the longest substring length is just by figuring out each and every substring. Find all the substrings. And once you are able to find all the substrings, check whether that substring is having any duplicate characters or not. If it is having duplicate, discard it. If it is not having duplicate, if it is only having unique characters, then take it. And out of all of them, find the minimum length substring. So one of the approach to find all the substrings can be just run a loop for the start point of the substring and another loop, a nested loop, inner loop for the end point of the substring. That is A till B, A till C, A till B, A till G, and so on. Similarly, B till C, B till B, B till G, and so on. So one loop for start pointer, another loop for end pointer, and then third loop for finding the number of unique characters or finding the different characters. But what you can do is, instead of just having three loops, which will take n cube time complexity, you can also just combine the logic for the end pointer with the counting of unique characters. That is, while you are just including every end character in the substring and forming a new substring, just count how many unique characters are there. Are there number of unique characters equal to the substring length? If it is, then all characters are unique. So that would only take two loops, but still its time complexity will be n square, which is a good enough solution for a brute force. That is a basic solution, but not going to be suffice for the most optimized solution. When it comes to most optimized solution, we have to think in maybe linear time complexity, that is even better than n square. And when it comes to linear time complexity, we have to run a single loop while running over the string. We have to check whether the current character which we are including is already there or not. If it is already there, we should only include it once. That is, if we will start from starting, A is present right now only once, B is present right now only once, C is right now present only once. But as soon as I take next B, it is already present. And if it is already present, I have to discard it. But since I want a substring, some strings are contiguous, same as subarrays. You can't have a character in between which you are discarding right away. You can't have a substring 0, 2, 3. You have to have a contiguous substring. So if you have to discard B, you also have to discard A, because if you want this particular substring, this particular B character, you have to discard all characters till the previous B. Then I will do what? I will include G, I will include E because it is unique, I will include F, I will include G. But as soon as I include G, as you can see, G is already there. So exclude or discard all the characters till the previous D, including previous D. Why? Because we can't take repeated characters. So where is the last occurrence of the current character present, that we need to store in some data structure, because we can't run another loop to find where is the last time G was occurring, where is the last time B was occurring. That will obviously take n square time complexity overall. So what we can do is we can maintain some data structure which will store the last occurrence of a character, and what is the best data structure to search whether what is the last occurrence, and also to insert the last occurrence of a character. Since we need the character, comma, the last occurrence of that character, that is the integral value. So we need a pair of char comma int. We need a pair of two types of data, the character corresponding to the last index. And what is the best data structure which will store all the key value pairs? It will be a hash map, or you can say we have to use hashing algorithms. So key will be nothing but the character, value will be nothing but the last index where the character is present. So we are going to make a hash map, or you can say we are going to use a hashing algorithm. Hash map is known as different things in different languages. It might be known as unordered map also. Once we are making a hash map of the key value pair as character combined, we will check whether the character is present in the current substring or not. But for the current substring, we need to have two pointers, that is the left pointer and right pointer. Where is the current substring starting? Where is the current substring ending? That is, when we are having the substring A till C, it is from 0 to 2. But now when I will include the third character, I have to discard the 0th index and the first index. That is, now the substring will be from 2 to 3. Then I will include 4, 5, but then I will include as soon as 7, the G index again. I have to discard all the occurrences till previous G. So new substring will be from 5 to 7. That is left till right. So we have to maintain two integer variables, two indices, left pointer and right pointer. Initially, we can assume that both the pointers will be at 0th index, or we can assume both the pointers are empty. The current substring which is having unique character is empty. What we are going to do is right pointer will try to include elements in the substring, as you can see, because whenever we are going to a new character, we are including it in the substring. But what will a left character do, or the left index do? The left index will try to remove all the characters till the previous index. That is, if I am saying I am including this B, I will exclude all the occurrences till previous B. So left pointer will help me in doing that. It will exclude all the previous occurrences. So initially, hash map will be empty, and we are going to start the logic by including characters using right, excluding characters using left. So left will be used for exclude, right will be used for include. Let's start including first of all, because we will only exclude if there is repeating character. We have to try to get the maximum length, and in order to get maximum length, we have to include as many characters as possible. So let's start by including. First, if we are including A, is it repeating? No, in the hash map, there is no character present which is having value A. So we can include A, no problem. And now the last occurrence of A can be said as 0th index. A is present at 0th index, key value pair, character comma integer. Next, let's try to include B. But before that, we also have to find the maximum substring length. So currently, what is the length of the substring? You can say the current length of the substring is right minus left, 1 minus 0, that is one length, only A was the substring. So the maximum length will be right minus left. So you can say the length, if I am saying the length variable is the answer, it will be right minus left, which is 1 right now. Initially it can be 0 because it is empty, but now it is 1. And we will check, can we include B also? Yes, we can include B because it is not present till now. At the first index, we will include it. Can we include C also? Yes, we can include C at the second index. And also the length will become 2. And now, as soon as you do third index, the 3 minus 0 will be 3 length. Now, if you will include B, B is already there. B is at the first index. Is the first index within the substring? Is it within left to right? Yes, of course. First index is within the substring. So within the same substring, we can't have two occurrences of the same character. We can't have repeating characters. So what we need to do now, we need to update the left pointer to discard all the characters till the previous B, till the first index. So if I am going to discard all of these characters till the previous B index, what we need to do is we have to just update the left pointer and go to the previous index of B plus 1. That is from 2 to 3 will be the new substring. And of course, as soon as I will do right plus plus, I will check what is the length. Length will be 4 minus 2, which is 2. It is not the longest length, but it is having unique characters only. C comma B, it is only having unique characters. Even if you are not doing right plus plus, if you want to calculate length before doing right plus plus, you can do right minus left plus 1. That is 3 minus 2 plus 1 is the length. There are two characters. So 3 minus 2 plus 1. Now, what we are going to do, since B is already discarded, should we let remain B at the first index in the hash map? Actually, no. Why? Because now in the current substring, as you can see, B is present at the third index. So while we are discarding the element and including it, we should update the index in the hash map also. We should make the B occurrence at third index. So G we will include at the fourth index because it is occurring for the first time. What is the substring length? 4 minus 2 plus 1. I have not updated right pointer till now. So 4 minus 2 plus 1 will be 3. 3 is already the answer. So don't update it. We have to find the maximum answer. Can we include E? E is not present in the substring as well as it is not present in the hash map, as you can see. So we can include it at the fifth index. As soon as I include it, I will say 5 minus 2 plus 1 is a 4 length. 4 is also the maximum substring, the longest substring. Now I will try to include F. F is also not present. So F we can also include at sixth index. Now see carefully. We are having G character. G is already present in the current substring at the fourth index, as you can see in the hash map also. And now since G is present, we have to discard it. So we have to discard only G? No, we have to discard all characters till G. That is left will become the previous occurrence of G, which can be calculated or which can be fetched from the hash map, which is fourth index. So make the left index become 4 plus 1. Go to the next index of that. So left will become fifth index. What is the length? The length is 7 minus 5 plus 1, 3 length. It is not more than 4. But should we also update the occurrence of G as now the seventh index, the current index? Yes, because next time it will be there, it will be present at the seventh index, not the fifth index. Next, we will check whether A is already present or not. And you will see that A is present in the hash map. Although is A present in the substring, the current substring is not including all these characters. Actually, all these characters till 0 to 4. A is present at 0th index. The last occurrence of A was at 0 index. In the current substring, A is not repeating. So no problem. We should not update left pointer. We should not say that discard A. Although what we should do is we should update the occurrence of A. We should say A is now occurring at the 8th index. That we should need to do. But we can't say that left pointer will become 0 plus 1 or the previous occurrence of A plus 1 because that is already discarded. A is not repeating. And what is the length? It is 8 minus 5 plus 1. 4 length only. 4 is already the maximum. Right plus plus F. Should we discard it? F, the last occurrence was at 6th index. It is within the string. 6 is within the string. It is more than equal to left. And if it is within the substring, what we need to do? Discard all the characters till last occurrence. That is, make the left become 6 plus 1, last occurrence of F plus 1. And also update the F occurrence as 9, the current index, right index. Right plus plus, what is the last occurrence of G? G's last occurrence is 7. So since it is equal to left, we are taking the substring from left till right. So we'll discard G. That is, we will make left become 7 plus 1 and also update the G's occurrence as a 10. The current substring length is of course only 3. Do not update the answer. Then we will make the character E. Is it present in the string? It is present at fifth index. It is not within the substring. So it is already discarded. If it is already discarded, don't discard it. What is the length? It is 4. It is also the maximum. So finally, we can say as soon as the right pointer is becoming plus plus, there is no more characters to be included. And if there are no more characters to be included, the approach is done. And finally, we are able to say the longest substring length, which is not having any extra characters, not repeating characters, is 4 length. In how much time? Since we were running a single loop on the array, on the string, only one time, like you can say using left pointer plus using right pointer, n plus n, it will be linear only. And what about the optimized approach space complexity? Since we are going to use a hash map data structure, extra data structure, the space complexity will also be linear because in worst case, there can be the entire string having different characters. Although it is not possible, you can only have 256 different types of characters. So you can also say it is order of 256 in worst case. But in general, if it will not be a string, if it will be an array, in that case, it will be linear only. So you can say it is either order of 256, which is almost constant, or you can also say it is linear in terms of if there are all the characters different or all the elements are different while applying the two-pointer technique. And which kind of two-pointer technique it is? The approach which we are actually using, since we are having a window from left to right, but this window size is not fixed. Sometimes the window size is increasing, sometimes the window size is decreasing, but window is shifting, it is sliding. So it is a sliding window technique. But since the sliding window is not of the fixed size, it is a dynamic sliding window technique. So the current approach, the most optimized approach which we have discussed, is known as dynamic sliding window approach, where we are having a window from left to right, a substring, which is shifting and also increasing, decreasing size according to left and right pointer. So let's do what? Let's go to the instruction manual. Actually, let's write the instruction manual. So first of all, what we have to do is we have to create a hash map of key as character and value as integer. That is the character. What is the last occurrence of that character in terms of index? Initially, we will have empty hash map, but one by one, we will run a loop over the string on the right index, on the right character. So run a for loop over right character. Why? Because right character is going to include the characters. Over right index from 0 to strings length minus 1. So two strings last character, two strings last index. That is n minus 1 if string is of n characters. So while running the loop for right character, what we will do, we will try to include it first of all. But before including it, if it is already present, we have to discard it by updating the left. And where should we initially set left as? We can initially set the left as 0th index only. So set left pointer as 0th index only, 0 value. And then check, is the previous occurrence of the current character, is if the previous occurrence of current character at the right index is within the string, within the substring. That is, it is in the range left till right. What we can say is we have to discard all the characters. Then what we have to do is then update the left as what? Update left as the previous occurrence plus 1. Previous occurrence or previous index, you can say plus 1, previous index of the character. And how will you get the previous index? You will get it from the hash map. So if the previous index of the current character, we can let it stored first of all in a variable. So store previous occurrence of current character at right in a variable, let's say previous. And now, instead of all of this, we can just say if previous is within the range of the substring, if it is within the substring, then update the left as previous plus 1. So first get it in a variable using what? Using hash map. Now, after we are getting the updated left pointer, we will also update the hash map. That is, we will also put the character with the current index in hash map. We will update the hash map. Now we will check what is the length. Is it the maximum length? Because every time, whatever the window is, we have to check the length of the window by doing right minus left plus 1. And initially, what should we assume the answer? Set answer length as 0. Because initially, we can assume it is empty length. Now we have to find maximum, or we can say store maximum of what? Of answer, and right minus left plus 1 in answer only. That is update the answer with whatever is the new maximum. And finally, we have to return the answer. So this is going to be the approach for finding the length of the longest substring without repeating characters using a hash map, that is linear time, linear space. With that, we will be writing the code. So first thing we discussed was we have to create a hash map because we need to store where is the last key or last index where the current character is present. So for that, we will be creating a hash map of key as a character, value as integer, and let's say the hash map name is HM. We can name it anything as you want. We have to set the left pointer because for a substring or a sub array, we need a left pointer and a right pointer for the starting index and the ending index. Left pointer will start from 0, and also the answer variable should be set to 0. Both of these variables we have to set to 0 value. So let's just set them in the same line. The left as well as answer length, the maximum substring length will be 0. We will run a loop for the right index because for right always we have to include one character. So for right pointer, we are starting from 0, going till the last character, that is strings dot length minus 1. And what we have to do is we have to check what is the character, whether the character is a repeating character or a non-repeating character. So for that, let's just check whether that same character is already present or not. So I am storing the character in a variable, although you can directly use it also, it is your choice. So string dot char at right, I am storing it in a variable ch, and I am checking whether that character at right is already available in the hash map or not. If it is not available, we can consider it as -1 or null or anything. So check the previous occurrence. We can say get the previous occurrence in a variable which is previous is nothing but hash map dot get the current character or the character at right. Or even if you just want to directly use it like this, you can also use it like this. So get the previous occurrence. If it is within the string length, within the substring left to right, that it is more than or equal to left pointer. If previous is more than or equal to left pointer, but before that, we also have to check whether previous exists or not. Because if previous is null, then we can't do anything. That means if it is not existing till now, obviously we don't have to discard any characters. So if it is not equal to null and if it is within the substring, then only discard the characters till the previous index that is left up will get updated as previous index plus 1. And as soon as we are doing it, what we have to do is we are also going to update the hash map with the new key value pair. So we will say in the hash map, just put for the same character that is s.char at right, the new index that is a right index, current index. Store maximum. We are always trying to update the window with the maximum length possible. Right pointer will include characters, left pointer will discard characters or exclude characters. Whatever the current substring, the current window length is, that is from left to right window length will be right minus left plus 1. Check if it is maximum or not. So answer will be maximum of math.max of answer till now or right minus left plus 1. Whatever is the new answer, we will update it. And finally, we will return the answer. So let's just run this code. It was having a simple single loop only, not that much parts or components, to be honest. It was just having a single flow. If you are able to understand the flow, you are able to get the logic also, or you can say why we are using hash map. So as you can see, the sample test case is working as perfect as it can. Let's just submit it and see if all the test cases are also getting accepted or not, even including the corner cases if there are any. So as you can see, all the test cases are getting accepted. It will also just see whether the previous character is including or not. So there is no corner case as such. And since the string should be at least of one length, we are saying that answer will always get updated. Even if the input string is an empty string, still we are saying the answer is 0 only because empty string is of 0 length. So there is no corner case as such, but as you can see, we are running a loop over the string for n characters. The loop will run for n times. Inside the loop, we are just using put operation or get operation. These operations are constant in average case for a hash map in Java. So overall, we can say the loop or the entire code in total will take linear time. And since we are using a hash map, in worst case, it can consist of 256 different kinds of characters. So in worst case, it will be order of 256. Although if you consider instead of a string, if there is was an array, you can just say it is linear because in that case, it will be having in worst case n different pairs where n is the array size. So that is the time and space complexity. And with that, we are done with the problem. Find the longest substring without a repeating character.